Okay, so today I want to review the for areas and the volumes. So this is like outline. The first, I want to talk about the area first. Next, I can talk about how can you find the volumes. The graphs like given. This one is like f of x. The g of x is given. The step 1, you need to find the point of the intersection. Solve f of x equal to g of x for x. X is like find A and B. Step 2, find the area between two curves. Integral from A to B, top on function minus the bottom function. This is the idea. So this is like equation. Find the area of the region enclosed by y equals x cubed and y equals x. So graphs like this. So what does it mean? You can just sketch the graph. The y equals x cubed. The y equals x cubed is graph like this one. This one. The y equals x is, this is y equals x cubed. The y equals x is a line. This one. So you need to find this area. This area. Find intersection point. This one. How can you find intersection point? Step 1, find intersection point. How can you find? So like this. Step 1, x cubed equals x. You subtract x from both sides. The factor of x squared minus 1, factor more, x times x minus 1 times x plus 1 equal to 0. The x value is 0, 1, minus 1. We have 3 numbers. So next, find area. What's like area? So like this. So what does it mean? You can find this area and this area. So from the minus 1 to 0. Top on function is the red curve, y equals x cubed minus, the line is blue one, x, plus from 0 to 1. The top one is x, bottom one is x cubed dx. So in this case, this is like a symmetric. This area is exactly same to this area because symmetric about the origin. This is 2 times integral from 0 to 1, x minus x cubed. Only use this area times 2, only twice. Same to 2, find entire derivative, 1 over 2x squared minus the 1 over 4 x to the 4 from 0 to 1. You can plug 1 into x, 1 over 2 times 1 squared minus 1 over 4 times 1 to the 4. So what happens? This one is 2 times 1 over 2 minus 1 over 4. The 2 times the 2 over 4 minus 1 over 4 is 1 over 4. 2 is crossed out. Answer is 1 over 2. This is whole idea for solving this problem. The next is, the consider range S then lies between two curves, x equals f of y, x equal to g of y, and between the horizontal line y equals c and y equals d. The where f and g are continuous function, f of y is greater than or equal to g of y for all y in the closed interval c to d. So like this. How can you find the area? Each area A is the next one. Always here, right boundary, the right boundary, minus small one, the left boundary, from C to D, from C to D. This is the whole idea. Exactly, right boundary minus left boundary. So where XR is right boundary, XL is left boundary. Was it like the area enclosed by the line x equals y square and parabola? This is like typo. This is parabola. This is a line. So what's that? You can draw x equals y square first. X equals y square is, graph is the like this one, parabola. This one is x equals y square. Next one, y equals x minus 2, the passing through 2 minus 2 and 2, graph is the like this. This one, passing through 2, this is like a negative 2. This is y equals x minus 2. You need to find intersection point. This one and this one. You can find intersection point, find this area. What's like intersection point? You can solve the y squared equals, you can solve for x, add 2 to the both sides, x equals y plus 2. So intersection point is this one. You solve the y square equals y plus 2. The subtract y from both sides, subtract 2 from both sides. This is the same to the y square negative y minus 2 equal to 0. The next factor, y minus 2, y plus 1 equal to 0. We have 2 y values. The first one, y minus 2 equal to 0, we have 2. Y plus 1 equal to 0, y is minus 1. So we have, this is negative 1 and 2. What's it like the area? The area is integral from minus 1 to 2. We have here, right boundary. The right boundary is here, y plus 2. Minus left boundary y square dy. You can find antiderivative, the y square over 2 plus 2y minus y cube over 3 from minus 1 to 2. You can plug 2 first, 2 square over 2 plus 2 times 2 minus 2 cube over 3 minus plug minus 1 square of 2 plus 2 times negative 1 minus negative 1 cube over 3. The 2 is crossed out, only 2 plus, this is 4 minus 8 over 3. This is like 1 over 2, distribute minus 1, negative 1 over 2. Distribute minus 1, the negative 2 times minus 1 is positive 2. This one is positive 1/3, distribute minus 1, minus 1/3. You can add these numbers. 6 plus 2 is 8. The negative 3, 8 over 3, negative 1/3 is negative 9 over 3, minus 3. And last one, minus 1 over 2. This is 5 minus 1 over 2. Final answer is 9 over 2. This is whole idea for solving this problem. The next tip. Was it like disk and the washer method and the cylindrical shell method for finding volume? Find the volume of the solid obtained by rotating the region bounded by y equals f of x, y equals g of x. X is equal to a, x equals b. The g of x is less than y equal to f of x, and a is less than y equal to b, about a specified line. Case 1. The rotating axis is horizontal. We always use disk or washer methods. The cross-section is disk. The A of x is pi times radius squared. The cross-section is a washer. The A of x is the pi times outer radius squared minus inner radius squared. How can you find the volume? Integral from A to B, the cross-sectional area, AX dx. Second case, the rotating axis is vertical. Use method of cylindrical shells. How can you find the volume? Integral from A to B, the 2 pi times radius of cylinder, height of cylinder, dx. Another one. Find the volume of a solid obtained by rotating the region bounded by x equals f of y, x equals g of y equal to c, y equal to d. The g of y is less than y equal to f of y, and c is less than y equal to d about a specified line. It's like the opposite one. First case, the rotating axis is horizontal. Use method of cylindrical shells. The volume V is integral from C to D, 2 pi, radius times height times dy. Second case, the rotating axis is vertical line. The use disk or washer methods. The cross-section is a disk. The AY is pi times radius squared. The cross-section is a washer. AY is pi times outer radius squared minus the inner radius squared. The volume V is the integral from C to D, AY dy. The problem, find the volume of the solid obtained by rotating the region enclosed by y equals minus x squared plus 4x and y equals x. The first, you can find the region. You can solve the factor out minus x, x minus 4. Was it like x-intercept? The x-intercept is 0 and 4, so graph is like this. Graph is 0 and 4. Passing through this one, we have parabola, so like this. Y equals x is this one, y equals x. We have this region. This is y equals x. So this top one is y equals the minus x squared plus 4x. You need to find intersection point. How can you find the intersection point? The intersection point is you can solve the negative x squared plus 4x equal to x. You can subtract x from both sides. So we have minus x squared plus 3x equal to 0. You factor out minus x. So we have x minus 3 equal to 0. So what is x? X is 0 and 3. We have x is 0 and 3. This one. So let me see. Was it like a rotating axis? The rotating axis is here, the x-axis. The rotating axis is horizontal line, is right? The rotating axis is horizontal line that we use the washer or disk method, disk or washer. So how can you make this kind of washer? This is like idea. I can show to you. Here, you can only choose x value between 0 and 3 and cut. You can cut this one, this segment. You have to rotate this segment about x-axis. Rotate segment. This point has one big circle. So this point has one small circle. We have washer. Washer. So we have like washer. This one and this one. You can find area between two circles. Was it like outer radius? Outer radius is I can use this orange one. This is center from here to here. This is orange one. Was it like this orange one? Here, the center of the washer is always rotating axis. You can connect to this segment. This longest one is rotating axis. So exactly, so this length is function value minus x squared plus 4x. So we have negative x squared plus 4x. This is outer radius. Was it like inner radius? The inner radius is this green one. The inner radius is same. Centered here, we have this one. Centered here, we have this one. This point is exactly function value on the line, just x. So inner radius is x. So was it like cross-sectional area A of x? The cross-sectional area A of x is the pi times outer radius squared, outer radius orange one, the negative x squared plus 4x squared minus inner radius x squared. The next, find volume. What's the volume? Volume V is the integral from here, 0 to 3. You can use intersection point, the dx. Exactly, integral from 0 to 3 and dx. This is like a volume. All right? So we have like this. So calculation is up to you. I don't calculate more. The 108 or 5 pi. Find the volume of solid obtained by rotating the region enclosed by the same function from the previous example, the minus x squared plus 4x, y equals x about y-axis. Graph is the exactly same, is right? Exactly same. This one, the exactly same. This one. So what's that? We have same graph. We have passing through here, going down, so like this. This is y equals minus x squared plus 4. You can draw y equals x. We have this region, intersection point 0 and 3, the same to the previous one. You have to rotate this region about y-axis. The rotating axis is vertical line. What does it mean? So we use the method of a cylindrical shell. Method of the cylindrical shell. This one. So how can you make a cylindrical shell? You can choose x value here and cut. Make a rectangle. Make rectangle. You have to rotate this rectangle about y-axis. We have cylindrical shell. Inside one has small circle. Outside one has big circle. We have a cylinder. We have like this one. Like this. So what is height? This is like, sorry, radius is this one, the average radius. So what's that? So from here to here, center is rotating axis. So just to connect to the midpoint of this rectangle. This is exactly radius. Radius is from here to here. Exactly x. The next one, what is height? Height was green one. This is height. This height is So exactly same to this one. The length between two values. So this function value is negative x squared plus 4. This function value on the line just x. So this one is, so top one minus bottom one, minus x squared plus 4x. Sorry, this is 4x. So 4x minus x is negative x squared plus 3x. What's it like a volume? The volume V is integral from here, 0 to 3, same. The 2 pi times radius x times height minus x squared plus 3x dx. So like this. So we have this result. Next one, find the volume of solid by rotating the region enclosed by y equals minus x squared plus 4x and y equals x about y equals minus 2. So was it like a graph? So similar one. So we have same things. So here we have parabola. You can draw line, intersection point, same, 0 to 3. We have this region. Rotate this region about y equals negative 2. You have to rotate about y equals negative 2. So what's that? The rotating axis is horizontal line. So we have the washer or disc. Washer or disc. How can you make a washer or disc? The same. You have to cut this one. So you have to rotate this segment about the y equals negative 2. So we have washer. Washer. So what is outer radius from here to here? The outer radius, what's that? This outer radius is here. You can connect this one to the rotating axis. This is center of a rotating axis. You can connect till here. This one. Was it like this one? This function value is negative x squared plus 4x. So this length is this one plus this length is always 2. So exactly the 2 plus negative x squared plus 4x. This one. What is inner radius? Inner radius is green one from here to here. So what's that? From here to here. This one. So same. This length is 2. So this one is exactly function value x. This is x. So 2 plus x. Inner radius is 2 plus x. So was it like cross-sectional area? The A over x is pi times outer radius 2 plus negative x squared plus 4x squared minus inner radius 2 plus x squared. You can take integral from 0 to 3. From 0 to 3 dx. This is like a whole idea for solving this problem. This one. 10th one, find the volume of the solid obtained by rotating the region enclosed by y equals minus x squared plus 4x and y equals x about the x equals negative 2. So how can you solve this problem? Very similar. Only difference is like this. We have parabola. the y equals minus x squared plus 4. We have y equals x. Find intersection point 3 and 0, this region. We can rotate this region about x equals -2. Rotate about x equals -2. So rotating axis is vertical line. You have to use the method of cylindrical shell. How can you make a cylindrical shell? So this is the idea. This blue one, you just choose x value between 0 and 3 and cut. Make a rectangle. You can rotate this rectangle about y equals -2. We have one cylinder. One cylinder. Like a cylindrical shell. So what is this rectangle? This rectangle is here. This one, this is a rectangle. So what's it like radius? The radius of this one is like orange one. From here to here, the radius, the average radius. The center is here. Connect to the rectangle here. So this length is exactly radius. What's that? From here to here. Here to here. So this length is 2. This length is x, like 2 plus x. What's it like height? Height is green one, from here to here. This is height. The height is this one. This one. This function value is the minus x squared plus 4x. This is x here. This one is function value of y equals x, just x. The difference of two function value, curve minus x squared plus 4x minus x. Same to negative x squared plus 3x is height. What's it like volume V? Here, the volume V is integral from the 0 to 3, the same, 0 to 3. 2 pi times radius 2 plus x times height negative x squared plus negative x squared plus 3x dx, and calculate this whole idea. This one. The next example, find the volume of the solid obtained by rotating the region enclosed by y equals negative x squared plus 4x and y equals x about the y equals 5. So how can we find the area? We can use same method here. Only rotate this region. We have this one, this region from 3. So what's it like y equals 5? Here, y equals 5. You have to rotate this region about y equals 5. The rotating axis is horizontal line. You can use washer or disk method. How can the decide washer and disk? So like this. You can choose x value between 0 and 3 and cut this region. We have this segment. You have to rotate this segment about y equals 5. This point has one big circle. This one has a small circle. We have exactly washer. The washer. You can find the area between two circles. I can do that. You can find outer radius. Outer radius is this one. What's that? Here to this one. The center is always this point. We can connect. to the end point of this segment, this end point. So this is exactly outer radius. What's that? This function value is exactly x, y equals x. What's that? 5 minus x. We have 5 minus x. So next, you can find inner radius. Inner radius is from here to here. This is center. Here to this one, this end point. This is like inner radius. What's that? This function value is curve minus x squared plus 4x. What's that? 5 minus this function value. So we have this one is 5 minus this function value minus x squared plus 4x. So what is like volume? Find the cross-sectional area first. This is the same to pi times outer radius 5 minus x squared minus inner radius 5 minus negative x squared plus 4x squared. Next, find volume. Take integral from 0 to 3. Integral from 0 to 3. This is the idea. You can calculate. Answer is this one. The next, last one. Find the volume of the solid obtained by rotating the region enclosed by y equals negative x squared plus 4x and y equals x. So how can you find this one? So similar. You can draw here the y equals x. We have this region 3 and 0. You can draw x equals to 5. X equals to 5 is this one. X equals to 5. You have to rotate the region about x equals to 5. The rotating axis is the vertical line. So we can use cylindrical shells. So what's it like cylindrical shells? How can you make it? This one. You have to cut between 0 and 3. This is like x and cut. You can make a rectangle. You have to rotate this rectangle about x equals to 5. We have y shell. Sorry, cylindrical shell. Sorry, cylindrical shell. So this one is same to here. This is like rectangle is here. So what is radius of this one? The radius is centered here, exactly this one, the middle point here. This is like radius. From here, center, only connect to this one, the middle point of rectangle. This length is exactly radius. What's that? From here to here. Here to here. So this length, what's that? This whole thing is 5. So this one is x, exactly 5 minus x. Also like a height is like a green one. Height is this one. This one is the height of rectangle. This point is point on the curve, exactly function value, negative x squared plus 4x. This one is on the line, y equals x. This is like x. So, what's it like exact volume? The volume now from 0 to the 2 pi times radius 5 minus x times the height. What's the height? Height is exactly this green one. What's like a green one? The difference between two function values, negative x squared plus 4x minus x. Exactly negative x squared plus 3x. So times high negative x squared plus 3x dx. This is